So very good morning to everyone. How are all of you? All well? So first, tell me, am I audible properly, visible, everything all right? Audio, video, everything all right, fine? Okay. Right. So today we are starting with symmetry. Symmetry of flower. So if we talk about symmetry of flower, so we are discussing about here three different type of symmetry. One is actinomorphic. Another one is zygomorphic. And third one is irregular kind of flower. Right, so actinomorphic is also called radially symmetrical or radial symmetry. Zygomorphic is called bilateral symmetry. And irregular flower is called asymmetric. Means no any other symmetry is there. Got the idea? So based on the symmetry, actinomorphic, radial symmetry, zygomorphic, bilateral symmetry, irregular, asymmetric. Now question arises, what is actinomorphic? What is actinomorphic flower? So actinomorphic is what basically when we cut the flower into two radial half, in any plane, passing through central axis. It is called actinomorphic flower. If we talk about diagram of the actinomorphic, I am just going to draw a sketch like this. Just a minute. Suppose that this is a flower. Suppose that this is a flower. Now we can cut this flower into two equal half in such a manner also. In such a manner also. Got the idea? In such a manner also. In such a manner also. From central axis, if I am drawing any radial plane, flower is going to cut into two equal half. So such particular conditions is called actinomorphic condition. Is it clear in the mind? Understanding about the actinomorphic came? And that's the reason I wrote in the definition, when we cut the flower into two radial half in any plane passing through the central axis. This is the central axis. Is it clear? Done. Now we are coming on the second type of the flower, that is zygomorphic. That is zygomorphic. Zygomorphic flower. Bilateral symmetry I already wrote earlier. So I'm drawing a zygomorph. So first I'm writing the definition. When we cut the flower into two equal half by only one vertical plane, it is called zygomorphic. I will come on the example also. So let me draw first the zygomorphic. Suppose that if a flower look like this, if a flower petal sepal arrangement, or you can say petal arrangement is like this. Now you can cut into two equal half by only this method. You can cut into two equal half by this way only. Getting the idea? One this side, another this side. So it is only one vertical plane in which flower is going to cut into two equal half. It is called zygomorphic. So I hope everybody understand about actinomorphic and zygomorphic. Now we are coming on example part of actinomorphic. Example of actinomorphic. What is the example of actinomorphic? What is the example of actinomorphic? Pin your response. Example of actinomorphic, I told you people before listening the class, you must read the NCERT. I just want NCERT example of actinomorphic. NCERT example of actinomorphic. Very good. Mustard, dhatura and chili. Mustard, dhatura and chili. Mustard, dhatura and chili is the example of which one? Actinomorphic flower. Now we are coming on the example of zygomorphic flower. Example of zygomorphic flower. Pea, bean, cassia, gulmohar. Gulmohar. Pea, bean, cassia, gulmohar are zygomorphic. So actinomorphic, mustard, dhatura, chili, zygomorphic, pea, bean, cassia and gulmohar. Well done. Now we are going to talk about asymmetric flower. Means flower not cut into two equal half by any vertical plane or by vertical plane you can write also. When we are not able to cut the flower into two equal half by any vertical plane, getting the things or not? You can just make a flower like this. Can we cut into two equal half by any plane? Any vertical, I am making a vertical plane. Is it divided into two equal parts? Got the idea? You just make one as this, another as this. It become more clear. Now you try to cut it like, it will not going to cut into two equal half. This one and this one is different. Getting the idea? So that type of example is which one? Asymmetric. Example is canna. Example is canna. So symmetry is over. Once again, see, it is a game of revision. Once again, you know everything here. So simply we want to not get a confusion. Actinomorphic. Example, it must be bang with you. Example of actinomorphic. Mustard, chili, dhatura. Zygomorphic, pea, bean, cassia, gulmohar. Asymmetry cannot. Now we are going to talk about the second thing, that is mocity. First we are going to talk about what is mocity. Mocity is number of members in a whorl. Number of member in a whorl is called which one? Or you can say number of member in a whorl or plant organ. It is called mocity. So based on mocity, there are three type of flowers are there. One is trimerous, another one is tetramerous, and the next one is pentamerous. Trimerous, tetramerous, and pentamerous. So what is trimerous? When number of floral leaf in a whorl is 3 or in multiple of 3. Number of leaf in a floral whorl is how many? 3 or in multiple of 3. It is called trimerous. Either it is 3 or it is, suppose that with an example I am telling. In Liliaceae family, how many perianth are there? How many, in perianth, how many tepal are there? Perianth is a whorl. Perianth is a whorl. In perianth, how many tepal are there? 6. 3 outer, 3 inner. Total 6. How many stamen are there? 6. How many carpel are there? 3. Are you getting the idea or not? So what we are finding, the number of floral leaf are 3 or in multiple of 3. An example of such condition is reported mostly in monocot. Monocot. So monocot is the example of which one? Trimerous. Example you can say as a individual example, lily. Understanding the idea? Trimerous condition. Now we are coming on tetramerous condition. Same, I am not writing that much story. Floral leaf are 4 or multiple of 4 in a whorl. 4 or in multiple of 4. It is called what? Basically tetramerous. Got the idea? Example of tetramerous, if we talk about, it is mustard family. Mustard family. Mustard family is which one? Brassicaceae. Brassicaceae family. You try to recall Brassicaceae family. And it is not a rule that every whorl following this rule. But we are just finding the majority. Suppose that in Brassicaceae family, if you open your NCERT, you will find in Brassicaceae family member, mustard family member, what floral formula is given? They have given Calyx 4, corolla 4. But who is not following this rule? A stamen given 6, carpel given 2. So out of 4 members, 2 are following this mocity pattern, 2 are not following, 6 is not multiple of 4, 2 is not coming under the multiple of 4. But beside of that, we are saying what basically? Tetramerous. Right? By 4 type of component we are finding, 2 are following. We are saying like this. Many times student came, suppose that if I am teaching right now a first year student, then which type of question will arise from them? They will ask, sir, if 12, 4 3s are 12, 3 4s are 12. Then we consider trimerous or tetramerous. If any floral whorl have 12, then we will find what are the another one. If it is 3, then we will consider under which one? Trimerous condition. If it is 4, then we will consider in which one? Tetramerous condition. Did you got the idea? Understanding the idea? Right? Now we are going to talk about pentamerous. What happened in pentamerous? Floral leaves are 5 or multiple of 5. Floral leaves are 5 or in multiple of 5. Multiple of 5. Example, such condition we are finding dicots. You can say mainly in dicot. Mainly in dicot. If I say all dicot are pentamerous, it becomes a wrong statement. If I say all dicot are pentamerous, it becomes a wrong statement. Why it become a wrong statement? Mustard is also a dicot and it is tetramerous. So it's not like all dicot are pentamerous, but yeah, we are saying majority are what basically pentamerous. So we just make a generalization statement. When we are saying dicots are pentamerous, it doesn't mean all dicot are there. You can say almost all are there. Majority are there. Example, Solanaceae family. In Solanaceae family, you see na calyx. In sepal have 5. In sepal are 5 in number. Petal are 5 in number. Getting the things or not? Stamen are 5 in number. But carpel are 2 in number. So one member not followed this rule. Getting the idea? Understanding the idea? So merosity is over. Understand the merosity? Trimerous, tetramerous, pentamerous, trimerous usually in monocot. Tetramerous I told in Brassicaceae family member. Pentamerous in majority of dicot. Done? So merosity is over. Now later on NCERT divide the flowering plant based on bract is present or not present. So I am here making bract. First just try to understand what is bract. So look, I already told about bract to you people. Suppose that here it is a flower and you assume, I am just changing the color here. What's happening? Here it is flower. It's just I make colorful petal like this, symbolic representation. Now I am going to make another one. This is calyx. Now make something more also. Suppose that this is what? And here it is carpel or pistil. Assume it is like a story. So it is calyx. It is corolla. Getting the things? Androecium. Unit is stamen and it is gynoecium. I just make a sketch of the flower. Now this structure is what? Pedicel. So if a small leaf-like structure arise from the base of pedicel, it is called bract. What is this bract? Small leaf-like structure arise from base of flower. I already told about it. It is called bract. Got the idea? Now I told earlier another terminology that is bracteole. So what is this bracteole? I am putting with the changing color. In upper part of the pedicel, below the calyx, when leaf-like structure is arising, it is called bracteole. Bracteole. Understanding the idea? So NCERT classify the flower into 2 categories based on bract is present or absent. If bract is present, flower is called bracteate. And if bract is absent, it is called ebracteate. So this is also over. Got the idea? So when bract is present, this Small leaf-like structure arise from the base of the pedicel. It is called bracteate. When it is absent in a plant, it is called ebracteate. Now we are going to move ahead. Give your attention. Now we are going to talk about classification of flower based on position of ovary. Classification of flower based on position of ovary. We are getting here three conditions. One is hypogynous, another is perigynous, and the third one is epigynous. So what happened in the case of hypogynous? Superior ovary is present. Why superior ovary is present? Why superior ovary is present? Because ovary occupy the highest position on the thalamus. Highest position on thalamus. Remaining whorl present below the ovary. This condition is called hypogynous condition. You got the idea? Can you write the example of hypogynous? Mustard. Next example is? Tell me. Mustard, China rose and brinjal. And brinjal. Now we are going to talk about perigynous. What happened in perigynous? I am writing here half inferior ovary. Half inferior ovary. Why half inferior ovary is present in perigynous? Let me explain with the help of a diagram. So I am making the diagram of perigynous condition here. See, this is the thalamus, like this. And if it is the thalamus, you can see like this is the ovary. Got the idea? So this is the rim of the thalamus. Rim of the thalamus. This is the center of the thalamus. So what you are finding? Ovary present in center. Ovary present in center and remaining whorl. You can say about remaining whorl like suppose that here it is calyx is arising. This one is assume who is there? Corolla is there. Then you can say it is stamen are there. So remaining whorls, what happened? A remaining whorl arise from a rim of the thalamus and present almost of same level. These three whorls are arising from the rim of the thalamus, and they are present almost at the same level. Who is present in the center? Ovary is present in the center. So you are finding cup shape like a structure is forming. Thalamus is forming cup shape structure. So this is the center and this is the rim. Did you got the idea? So these are the conditions we are finding in perigynous. If you talk about example of this category is plum, peach and rose. Got the idea? Perigynous over. I will show the diagram also, the actual diagram of the NCERT, don't worry. Now we are just going to move on the epigynous. Let me finish in writing word, then I will show you the diagram and explain also epigynous. In epigynous, what we are finding, inferior ovary is there. Inferior ovary is there. What happened in this condition? Thalamus fuse with the ovary. And remaining wall are present above the ovary. Example of this epigynous condition is guava, cucumber and ray florets of sunflower. A ray floret of sunflower. Got the idea? So this is about the epigynous condition. Right? What we are discussing now, see through the diagram. What happening? See, this diagram is hypogynous. What we are finding in the hypogynous condition, this is the thalamus, this is the ovary, and these all are the floral leaves. All floral leaf you see are present below the ovary. Ovary is finishing here. Got the idea? And all floral leaf are present below the ovary. Getting the idea or not? That particular condition is called what basically? Hypogynous condition. So who is occupying the highest position? Ovary occupying the highest position, remaining other walls present below the ovary. Got the idea? Clarity came in the mind. Now this question came this year in NEET. They have given this diagram and they ask you which type of condition is it. So both are perigynous condition. These two diagrams are given in this year in exam. So look, in both the cases, what condition is there? Cup shape structure is formed by thalamus. Somehow one deeper cup, one is somehow such kind of cup. And in center, who is present? Ovary. Ovary in center. And this is the rim. All other walls are arising from the rim and arise from almost same level. That type of condition we are finding in which one? Perigynous condition. So this perigynous condition, these two both are the perigynous condition. Getting the things or not? Ovary is half inferior, and example is plum, peach and rose. Now if we talk about the epigynous condition, inferior ovary. Look here, this is ovary. I am just telling you. Suppose that this is the boundary of the ovary. Okay. and this is style, stigma. Got the idea? This is the female reproductive organ. And this is what basically thalamus. Thalamus fuse with the ovary. These yellow color structure is what? Ovule. I make it red. This is ovule. And where it attach here, this one is called what basically? Placenta. So what you are finding? Thalamus is going to fuse with ovary. And when it is going to fuse with ovary, ovary come in the lowest position and remaining floral leaf arise above the ovary. So here ovary become inferior in lowest position, and that is the reason we are saying this condition is what basically epigynous condition. An example is guava, example is cucumber, example is ray florets of sunflower. So it's done. Can we move ahead? Give your attention. Now, we are going to talk about calyx. I told some basic idea about the calyx. It is the outermost wall. Its member is called sepal. It is usually green color whorls, and its function is protection of the flower in the bud stage. These are the story I told about the calyx. I hope you are aware about. Now simply I am writing calyx, either sepal or fuse or free. Based on that, there are two type of calyx are there. One is polysepalous. Another is gamosepalous. So polysepalous condition we are finding present. These are the finding condition. What is this? Sepals are free. Sepals are free. More than one sepals are there and all are free. They are not fused. They are separate from each other. That is called polysepalous condition. Gamosepalous condition, sepals are fused. Got the idea? So these are the terminology mentioned in the textbook NCERT. Now we are coming on the corolla. Basic story I told in the last class. It is second whorl from outside. It is usually bright colored. Its major function is attract the pollinator, and both calyx and corolla is called accessory whorls because it help in reproduction, not participate in reproduction. So here I will also say two terminology. One terminology is polypetalous and here gamopetalous. So if you talk about polypetalous, example, not example I am writing here, here we are talking about what the condition, petals are free. Petals are free, and gamo here using for fused petals are called gamopetalous. Got the idea? So there are so many different flowers are there based on shape of corolla. Got the idea? And based on shape of corolla, how many condition are we are finding? Suppose that corolla may be which shape? Wheel shape. Corolla may be which shape? Tube shape. Corolla may be which one? Bell shape. And corolla may be which one? Funnel shape. Funnel shape. So there are so many different forms of the shape of the corolla are there. Out of so many different forms, NCERT wrote about these 4 forms of the shape. If you want to look the appearance of flower based on shape of the corolla, I am showing you through a diagram. Have a look here. Give your attention. That file came, not came, I doubt. I think that slide not came here. Not copied. It is in my pen drive. It is not opening. See. I'm not going to talk about all the shapes. Simply I want to give you visualization of. You just look this. You just look this. This is which shape? It is looking like a wheel shape corolla. Got the idea? If you talk about this one, this is bell shape corolla. If you look at this one, this is a funnel shape corolla. If you look at this one, here in this flower you just focus, it is what basically? Tube shape corolla. So there are so many different variety of forms are there. Getting the idea? I just told about this one only, not about the all. Getting the idea? Is it clear? Done? Over? So these are the different possible petal arrangements. Out of that, 4 arrangement is mentioned in NCERT: wheel, bell, funnel, and tube shape of corolla. Is it done? Over? Clear? Can we move ahead? Yes. Now we are coming on Androecium. Regarding perianth, I told in the last class, na? Perianth and tepal, these things I told, I hope I remember it. You just put yes or no. When calyx and corolla are fused together, it is called perianth, and a single leaf is called tepal. An example is lily. Got the idea? Now we are going to talk about Androecium. Right? So if we discuss about the Androecium, give your attention. It is male reproductive whorl. It is male reproductive whorl, first thing. Second thing, its unit is called stamen. Right? Now we are going to talk about the structure of a stamen. A structure of a stamen. If you want to talk about the structure of a stamen is also called what? Microsporophyll. If we talk about the structure of a stamen, how it look, I think I have to take a bigger slide. So look here about the structure of a stamen. It is looking like this. So here stalk of the stamen is there, it is called filament. And here knob like pinhead like a structure is there, it is called anther. If you talk about the anther, it is how many lobe are there? Lobe 1, lobe 2. So if you talk about anther, it is usually bilobed. It is usually bilobed anther are there. Got the idea? It is usually bilobed anther are there. Now, if we talk about in each lobe, two chambers are there. If we cut the TS of this anther, after cutting the TS of the anther, we are getting some such kind of a structure. You just think like it is some such kind of a structure is there. I am making different color for different lobe, so you can understand easily. This is one side of the lobe. It is A lobe, one first lobe, it is second lobe, and each lobe have two chamber. A, B, it have two chamber, C and D. So each lobe have two chamber. Getting the things or not? Each lobe have two chamber, and hence we are telling it a dithecus. It is dithecus. And each chamber have a name. This is a chamber, this is a chamber, this is a chamber. At four corner, four chamber are there. So each chamber is called what? Basically microsporangium. Microsporangium, or you can say pollen chamber. Later on it convert into pollen chamber, or you can say pollen sac. Pollen sac. Got the idea? So these microsporangium later called pollen chamber or pollen sac. So how many microsporangium is there? 4 microsporangium. Hence a typical anther is tetrasporangiate. Tetrasporangiate. Got the idea? And inside this chamber, pollen chamber, who is forming later on? Pollen grain. Pollen grain. So later on, formation of pollen grain occur in these pollen chambers. Got the idea? So I hope you understand the meaning of bilobed, understand the meaning of dithecus, and understand the meaning of tetrasporangiate. Microsporangium is later on, this chamber is called microsporangium. Later on, it is called pollen chamber or pollen sac. I hope every term is clear. Is it done? Okay, right? Now I am just writing. NCERT wrote, you also note about it, कि a sterile stamen, such a stamen where pollen grain is not forming, a sterile stamen is also called a staminode. So staminode is what? Basically sterile stamen. What is the meaning of a sterile stamen? Where formation of pollen grain not occur. Got the idea? Is it clear? Is it done? Can we move ahead? Now we are moving ahead. So this is about the structure of the stamen. Now we are going to classify the stamen based on its number. Classification of stamen. Oh, ho. See. Okay, just a minute. We left aestivation. So what to do? First I finish the stamen, then continue on aestivation, and should I back and start? Just give your input. Aestivation we missed, na? Can we go for aestivation first and then go for further classification of a stamen? First I finish it and then go for. First finish, na? It started, so finish it, then I will tell about which one. Aestivation as well. So look here about a stamen. Classification of stamen based on its number. Based on its number. So here stamen is there. So one stamen is there, one condition. Another condition is called many stamen is there. Many stamen is there. One stamen is called, we use a terminology for it, monoandrous. It is not written in NCERT and no one will ask you. So I am also not focusing on it. So when many stamen are there and if it is free, two conditions are there and another condition it is fused. If anything more than one, there are two conditions always, either it is free or it is free. So if more than one stamen are there and all stamen are free, that is called polyandrous. That is called polyandrous. That terminology mentioned in NCERT. Many free stamens are called polyandrous condition. Now, if it is fused, there are two possible fusion are there. One is called cohesion. Another is called adhesion. What happen in cohesion? Stamen fuse with stamen. And adhesion, stamen fuse with a stamen fused with other wall. Fused with other wall. It is called adhesion. NCERT wrote na कि polyandrous condition is there when stamen are free or stamen are fused at variable degree, varying degree. Getting the things or not? So here fusion is two possible type, cohesion and cohesion. Look here. When same type of things fuse together, it is called cohesion. My hand is fusing like this. It is cohesion. This hand fused with this hand. It is cohesion. Got the idea? And my hand is fusing with the board. It is adhesion. Did you got the idea? Cohesion, adhesion. Same type of things, cohesion, two different things fused together, adhesion. Clear? Understand? So fusion are of two possible type in a stamen, cohesion and adhesion. Now we are going to talk about cohesion. Cohesion of the stamen. Right? So in a stamen, three possible type of cohesion are there. And I will write all three possible type because it is written in lab manual. Three possible type of cohesion is there. One is adelphous condition. Adelphous condition. Another one is syngenesious condition. And the last one is synandrous condition. Synandrous condition. Did you got the idea? So adelphous condition, I am making more than one stamen in diagram. Try to understand it. I am making here two stamen. It is more than one, na? More than one. More than one poly. So here who is fused together? To whom I am joining? Filament are fused together. Here who fused together? Anther is fused together. And in this case, stamen fuse in entire length. Anther also fused, filament also fused. So these are three conditions of cohesion are there. These are the variable degree of cohesion. Partial cohesion, complete cohesion. Got the idea? So in Adelphus condition, what we are finding? Filament fused and anther free. That condition is called Adelphus condition. Syngenesious condition, opposite. Anther fused and filament free. Filament free. This is called syngenesious condition. Synandrous condition, both, or you can say two stamen fuse in entire length. Two stamen fuse, two or more stamen fused in entire length. Entire length means what? Both, that is both anther and filament fused. That is called synandrous condition. Now I am writing the example of this one. So I am writing the example of syngenesious condition. Syngenesious condition example is sunflower. Or you can say family Asteraceae. Asteraceae family is in your syllabus, and there I also told you it is a very important character of member of family Asteraceae ki they have syngenesious condition. Got the idea? So syngenesious condition, did you got? You got the syngenesious condition. Who is fused? Anther are fused. Example of synandrous condition is cucurbitaceae. Cucurbitaceae is called gourd family. Gourds belongs to this family. Cucumber, watermelon, right now? These are from the, so in this plant you will find synandrous condition is there. Now you will ask a question, you not wrote the example of Adelphus condition. So I will first classify the Adelphus condition and then I will write the example of Adelphus condition. Adelphus condition is further classified. Adelphus condition is further classified into monoadelphus, diadelphus, and polyadelphus. So in monoadelphus, what you will find? One bundle of filament present. One bundle of filament. Example is China rose. In diadelphus, two bundle of filaments. Example is P. And in polyadelphus, more than two bundle. Bundle of filament. An example here is citrus. Got the idea? So this is the monoadelphus, diadelphus, and polyadelphus. One bundle of filament, mono, two bundle of filament, di, more than two bundle of filament, polyadelphus. Try to understand it with the help of a diagram, you understand it better. Look here. These are about the diagram associated with cohesion of stamen. So look here, this diagram. Here, how many bundle of filament are there? Thick filament are there. Only one bundle of filament is there in this diagram. Agree or not agree? And you just look here, number, all anther are free. These are anther, these all dot are what basically? Anther, and all anther are free. Only who is united? Only who is united? Filament is united and making one bundle. This is the example, the diagram of monoadelphous condition. It is monoadelphous condition. It is also written here. Now look this diagram, diadelphous. How many bundle of filament is there? One thick bundle and one thin. Here only one anther we are finding in this diagram, and here many are there. Got the idea? So I am writing a beautiful example for it, 9 plus 1 arrangement. 9 under the bracket means fuse. It is example of diadelphous condition. It is present in which family? Fabaceae family. Now you see here bundle of filament. More than 2 bundle are there. Look who is free. Anthers are free everywhere. It is polyadelphous. Such condition we are getting in citrus. Did you got the idea? Understanding came about it? Right? Now we are going to talk about which one? Syngenesis condition. In syngenesis condition, you are finding who is free. Filament are free. Who is fused? Anthers are fused. Such kind of condition we are getting in sunflower. Clarity came in the mind or not? Understanding came or not? And now I am going to tell you about synandrous condition. This and this both are fused. And that type of condition we got in which one? Cucurbits. So these are the different conditions of adelphous. Different condition of cohesion. This is called adelphous condition. This is called syngenesis condition. This is called synandrous condition. These two conditions deliberately I told because it is written in lab manual. Got the idea? Practical book it is written. These terminology are written. So I add on it here. Right? You don't think like it is out of syllabus. Okay? Can we move ahead? Right. Now we are going to discuss about classification of stamen. First we are going to talk about adhesion. Cohesion we have seen, na? Now we are going to talk about adhesion. So there are, if a stamen we represent with A, fuse with petal representing with C, fusing like this. If a stamen fuse with perianth like this. If a stamen fuse with gynoecium like this. Got the idea? So this condition is called if stamen fused with petal. This condition is called epipetalous condition. Epipetalous condition, an example is brinjal. And you can say family Solanaceae. Brinjal and family Solanaceae. Now, if a stamen fuse with tepal, it is called epiphyllous, or you can also say epitepalous. Both are same thing. An example of this condition is lily or family Liliaceae. Now, when stamen fuse with carpel, it is called gynandrous. This terminology not NCERT, even in not lab manual, so you can ignore it. Gynandrous, when a stamen fused with carpel. I wrote the possible way. An example of this condition is orchid. You can ignore this condition. Got the idea? But these two are very important. So adhesion of the stamen is also over. Got the idea? Adhesion of the stamen is also over. Now further we are classifying the stamen based on its length. Classification of stamen based on its length. Right? So based on its length we are classifying the stamen. So two condition is there. One is dynamous condition. And second one is tetradynamous condition. Tetradynamous condition. Okay. So if we talk about didynamous condition, it is stamen, 4 stamen are present. 4 stamen are present. 2 short and 2 long. All stamen are not of equal length. 2 short and 2 long. I am drawing a diagram for it. You will understand it better. Suppose that it is thalamus. Okay, ji? On this thalamus, stamen are arising like this. 2 inner stamen are shorter and 2 outer stamen are longer. Total how many stamen are there? 4 stamen are there. 2 inner is short, inner short and outer long. That condition is called didynamous condition and it is called 2+2 arrangement. 2+2 arrangement. Example of such kind of stamen is salvia. NCERT wrote it, but simply wrote the example. Unequal length salvia. I just decoded it. This is called didynamous condition. 2+2 arrangement is there. 2 inner is shorter and 2 outer is longer. Example of didynamous condition is salvia. Got the idea? Now we are going to come on the tetradynamous condition. Tetradynamous condition. Look here. So here in tetradynamous condition, how many stamen are there? 6 stamen are present. 2 outer short and 4 inner long. Got the idea? It is called 2+4 arrangement. So let me draw the diagram of this arrangement also. Look, here it is thalamus. In thalamus, stamen if arise like this is stamen 1, 2, 3, 4, 1, 2. 4 inner are longer and 2 outer are shorter. Such kind of condition is called tetradynamous condition. An example is mustard. Mustard, or you can say Brassicaceae family. Brassicaceae family. Understand the idea or not? So this is about the classification of stamen based on their length, didynamous and tetradynamous. Right? So this is also over. And now we are going to talk about what we skip. And that is which one? Aestivation. Be jump na? Aestivation. Right? That is the left part. Stamen over. After aestivation, gynoecium will remain only. So what is aestivation? Arrangement of petal and sepal in floral bud with reference to other member of same whorl is called aestivation. So NCERT wrote 4 type of aestivation: valvate, second they wrote twisted, third they wrote imbricate, and fourth they wrote waxillary. 4 different type of arrangement written in your textbook. Now you bang with the example. First I am going to say the example, then with the help of diagram I will explain each and every one. So if we talk about valvate aestivation, what is the example? What is the example? Tell me. Why should I write? Valvate. Pin your response. Calotropis is coming from you people side. Only one student is giving the answer. Is it correct? I'm just expecting more response. Calotropis. What are the example of twisted aestivation? Twisted aestivation. Twisted now. Fast. Without taking the help of NCERT. Just check your memory. China rose, lady finger, and cotton. Imbricate aestivation. Cassia gulmohar. Waxillary aestivation. P. bean. Now I am going to talk about these aestivation one by one, and I will give the detailed explanation of these there only. Right? Look at this diagram. This is the ray diagram, this is the actual diagram. If you see this ray diagram, this is the ray diagram of which kind of aestivation valvate? What happening? This is the ray diagram of which one? Valvate. What we are finding in the valvate, each petal or sepal are free. They are not overlapping the other. Either it is free or it is touching the other. Suppose that this is a petal. It is also a petal. This is one margin, this is another margin. If two petals are like this, they are touching, not touching. Or two petals are like this, they are touching. They may touch or may not touch. But what not happen? They must not overlap. Overlap the other. Cover the other. Either they may touch or remain free, but not covering the other. That type of condition is called volvet. So these both are volvet. This is the actual diagram, this is the ray diagram. You got the idea about the volvet? So non-overlapping. The member of a floral valves are either free or touching each other but not overlapping the other. That is called what? Basically volvet type of aestivation. Clear? Now second one is twisted. Twisted. What peculiarity you are finding here? You see any one leaf, either of sepal or petal, you will find every leaf have two margin. One margin get covered by other leaf and other margin is covering the others, and it is happening in every one. See, if you see about this leaf, this leaf, this leaf. So it is this side of this leaf covering this leaf, and this side of this leaf is covered by this leaf. So it is overlapping. One side it is means it is standing like this. Suppose that you are there, your friend are there, one friend this side, one friend this side. You are putting your hand on the neck of one friend, you overlap the other friend. Another friend is putting their hand on your this shoulder. So you are putting your hand in the one hand on another friend's shoulder, another friend putting their hand on your shoulder. So here another hand is there and your hand is on another, like this. So one side it is overlapping the other, by another side it get overlap from the other. That is called twisted. That is called twisted. And you better not twisted aestivation present in which one? What example you told about the twisted? Once again tell me. Fast, recall, twisted aestivation. Volvet you told, calotropis. Twisted you told. Fast, 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 fast. Lady finger, cotton, China rose, getting the things or not? Right. Now we are going to talk about imbricate, third type. In imbricate, NCERT wrote कि overlapping not occur in a direction, not in a pattern. When overlapping not occur in a specific pattern, that is called imbricate. That is written in NCERT. In lab manual, if you read, you will find here कि this is overlapping the other from both sides. This is get overlapped and remaining are twisted. What is the meaning of it? One is completely overlapping the others, another standing like this, one friend putting their hand there, another friend putting their hand here, means another get completely overlapped, remaining are twisted. So what is imbricate? One overlapping, one other, one overlapping, another overlapped, remaining are twisted. One overlapping, one overlapped, remaining twisted. Or when overlapping not in a specific pattern, it is imbricate. Example is cassia and gulmohar. Now, the last one we are going to discuss here is waxillary. Waxillary. Got the idea? So in waxillary, what we are finding? One posterior flower is there. It is posterior. That is called standard. Two lateral are there like this. These lateral floral leaf is called wings. And two anterior but fused. It is anterior anterior and fused, and this structure is called keel. Keel. So this is called 1 plus 2 plus 2 under the bracket arrangement, and it is called papilionaceous corolla. Papilionaceous corolla. That type of aestivation present in which one? Pea, bean, or member of family Fabaceae. This is the largest. So a standard overlapping the wings overlapping the keel. Getting the thing? Standard overlapping the wings overlapping the keel are fused. Keel are interior, standard are posterior, and it is called maxillary. It have another name also, descending imbricate. Maxillary is also called descending imbricate type of aestivation. So these are the type of aestivation mentioned in your textbook. Examiner can give, identify when no overlapping valvate, when everyone is overlapping the others and get overlapped by another also. It is twisted, one completely overlapped, another completely overlapping, it is, and remaining twisted, it is imbricate. And maxillary is what basically one posterior standard, two lateral wings and two anterior keels. It is called what basically? Maxillary aestivation. One more type of aestivation given in lab manual, and that is, I am writing fifth type given, quinquensial. Quinquensial. It is given in laboratory manual. So in quinquensial what happened? Two overlapping, two overlap, one twisted. How it is different from imbricate? In imbricate, one overlapping, one overlapped, one twisted. Here, two overlapping, two overlapped, and one twisted. Such kind of condition is called quinquensial aestivation. Simply term written in NCERT. That's the reason I told. I simply told how imbricate and quinquensial is different. Chances of asking is negligible. Simply it is written in lab manual, so I told you. So this is about the aestivation, and this is about the, I think time is there with us. Almost finished. So we can't start any new things and finish it. So Gynosium, we will just take care in the next class. After that, fruit and seed we will take. So next class agenda is Gynosium, fruit and seed. Okay, Ji, done, over, right? So bang on the example, revise the things, and you just identify this diagram. I told you pattern also. Otherwise, everyone looking same. No overlapping, valvate, one side overlapping, another side overlap, twisted, one completely overlapped, another completely overlapping, remaining are twisted, are imbricate. This like standard lateral wings and keels are there. It is maxillary. And for your information, two overlap, two overlapping, one twisted is called quinquensial type of aestivation. Got the idea? Done, over. So thank you very much. See you in the next class, right? With Gynosium as well as Perianth is example of, you can say like sepal and petal are fusing, na? So it is a result of adhesion. Okay, one student is, I think we can say what for Perianth. So two different type of whorls is formed. Bye bye. Have a nice day to all of you. Thank you very much for your patience for listening. Bye.